Hello everyone, my name is Dan. We'll be solving some interesting problems on physics. When I was in high school, I was interested in physics and the math. So I found this a Russian book that contained a lot of interesting and challenging problems in physics. So I used to solve many problems from that book. I believe there is no English version of that book, so I'll be translating it to English and then provide the solution. That book was very interesting for me. I loved that book a lot, but there was actually no formal solution provided in that book, so only the final answers. So I had to come up with the solutions for most of the problems by myself. Anyways, I believe these problems would be beneficial to anyone who wants to understand physics more, who wants to solve some interesting problems. Maybe you're preparing for university entrance examination, or planning to take SAT, GRE, or just want to have fun with some physics. Without further ado, let's go. So there is this one problem. It's actually not that challenging, but for some reason that book indicated it as one of the challenging problems. So we have three microphones located on the same straight line at points A, B, and the C, and they record a sound of an explosion at times TA, TB, and TC. The explosion occurs at a point O, lying on segment AC, but from this picture we can see it's actually between B and C. Yeah, that covers AC anyway. So find the distance of the segment AO given that AB equals to BC equals to L. And also at what point in time did the explosion occur? Okay, so let's dive into this problem. So here is the solution. Just to make my life easy, I'll copy this picture here so I can make additional drawings on it. So it says that the distance between A and the B is L, and the B and C is L as well, but we don't know the distance between A and O or B and O. So our goal is to find the distance AO. Okay. It's also asking when the explosion occurred. So what we have, what's given in the problem is we know the times TA, it's larger than TB, larger than TC. So mind that the TA, TB, and TC is not the time difference. It's an absolute time, whatever it is, but it's an absolute time measurement. So the microphone at point A measures the sound from O at time TA, and the B at time TB, and microphone C at time TC. And we also know the distance between AB and the BC is given as L. So given these parameters, we have to solve the distance AO and also find the time when the explosion happened. So the one thing is that we don't know the speed of the sound. We will just indicate it of sound as a V for now, but you will see that we actually do not need this parameter, but we might find it along the way when we do the calculation. Okay, so let's write down some basic equations and then we will go from there. So let's say that the distance between B and the O is given as x. So once we find this x, everything else would be easy to find. Okay, so let's write down our first equations. So we know that the distance OC is actually, from this picture you can see it's L minus x. So this also equals the velocity of the speed of the sound times the time difference, so TC minus TO. So T is the absolute time, so in order to find the time that it travels from O to C, we have to take the difference of the times, Tc minus To. To is a time when the explosion happens. The time of explosion. And then we also have the distance of BO, which is our x, and equals to the speed of the sound times TB minus TO. So again, we have to take the difference of time. And then the distance AO equals to, now it is L plus X. So we can see it from the picture above. So the distance AO is AB times BO. So AB is L, BO is X. And this equals to velocity times TA minus TO. I think this is the most important equations that we need. The rest of the things is just we need to play around with these three equations and substitute into each other. And then we can solve for all the unknown parameters such as speed of sound, the distance x, and also the TO, the time when the explosion happens. Okay, so we can start from the last one, AO. So it's L plus X equals to V times TA minus TO. And then we substitute equation number 2. Let me enumerate the equation number 1 and number 2, equation number 3. And then from equation number 2, we know that x equals to V times TB minus TO equals V times TA minus TO. Okay, so from here we just continue working on this. So L equals to V TA minus TO minus TB plus TO, and from here we see that TOs cancel and we get V times TA minus TB. And from here we can easily get that the speed of sound is TA minus TB. In the original question, it didn't ask to find the speed of sound, but this is a very useful result that we will be using shortly. Now we can use equations number 1 and number 3. So here we used equation number 3 and 2 to get this result. Now we can combine equations 1 and 3. So combine equations 1 and 3. So there we have L plus X equals to V times TA minus TO. And here we have L minus X equals to V times TC minus TO. And then we subtract these two equations. So when you subtract, you get 2x. And on the other side, you get V times, again, the T zeros go away because they're multiplying to the same speed of sound. And you'll get TA minus TC. So instead of V, we substitute our previous result, L over TA minus TB. And here we multiply it by TA minus TC. Okay, so from here we can easily get that X equals to L times TA minus TC divided by 2 TA minus TB. So this is another useful result. So we're not done yet because we are not interested in X only. we are interested in the section AO, and then AO means we have to add L to our result. So the distance AO becomes L plus X, and this is actually the final result that we get. And as for the TO, you can use any of the three equations to find TO, but I think the simplest one is just equation number 2. So we will just use equation number 2 to solve for the TO. It's a time when the explosion occurred, so T V times TB minus TO. So we substitute for X from our previous result, so it's L times TA minus TC divided by 2 TA minus TB equals, and for the velocity we again substitute this result, L over TA minus TB, L over TA minus TB, and then we multiply to TB minus TO. So eventually we get TA minus TC divided by 2 equals TB minus TO. So eventually we get TO, the time when the explosion occurred, is TB minus TA minus TC divided by 2. Okay, so this is the final result that we needed to achieve. There was not, it wasn't that challenging. The most important thing was to get these three equations, and after that you just do some algebraic manipulation and then obtain the results that you need. Okay, please, if you like this video, please subscribe to my channel. There will be more videos coming up, and if you have any questions, please let me know in a comment. Thank you.